Hello students, in this video I will discuss these sequences. So introduction of sequences and some basic definitions of sequences, and this is the syllabus of BSc 4th semester Mathematics paper 1, which is the syllabus of Karnataka University Dharwad. So now I would like to see the introduction, definition, limits of sequences and examples also we can discuss. So first I would like to discuss the introduction. In mathematics, a sequence is a list of objects which have been ordered in a sequential fashion, such that each member either comes before or after every other member, and so on. While a series is a sum of a sequence of terms, that is, a series is a list of numbers with the addition operations between them. So as we know that, so what is a sequence? Sequence is a list of objects, as we have seen that, which have been ordered in a sequential fashion, means which can be arranged in some systematic manner, that such that each member either it comes before or after or every other member that also. So but series can be defined as which is the sum of that sequence of the each terms that. So that is, a series is a list of numbers with the addition operations between them. So that means a sequence is an arrangement of any objects or any set of numbers in a particular or sequentially ordered, followed by some rule that. For example, suppose if A1, A2, A3, etc., which denotes the number of sequence, then 1, 2, 3, etc., which denotes the position of the terms of the sequences. Means keep remember where all those suffix which indicates that is the position of the terms of the sequences. So these sequences can be both finite and infinite. First of all, I would like to see that what is a finite sequence. As we know that a finite sequence is a list of terms in a specific order. A sequence has first and last terms. Means what? Any sequence which has a finite in number of terms, first and last term, it's kind of with that. It is finite number. So that is, we called it as a finite sequence. That order of terms of a finite sequence follows some type of mathematical pattern or logical in arrangement. That, for example, let us we take it a set of 1, 3, 5, 7 elements is the sequence of first 4 odd numbers, and which is an example of a finite sequence, because since this set of numbers which has finite in numbers, so that 1, 3, 5 which are first 4 odd numbers, so that's why which is a finite sequence. Now we shall see the infinite sequence. An infinite sequence of real numbers is a function f from natural number to real number whose domain is the set of natural numbers and the codomain is the set of real numbers. Means what? The set of functions which are mapping from natural number to real numbers. So this set we called it as a infinite sequence, that because in order to mapping from that function is mapping from natural number to real numbers whose domain is the set of natural numbers and the codomain is the set of real numbers. So that's why it is, and this is an infinite sequence. For considering an examples, you can take it a 1, 1, 1, 1, so that and so on like this, and there's no end at all. So that is, here it is, here to each number n, which is a member of natural numbers, the same number 1 is associated, and this sequence is denoted by 1. So now let us discuss some definitions. The bounded sequence. What is a bounded sequence? A sequence section is said to be bounded above. We have a bounded above as well as bounded below. So that first of all, a sequence is said to be bounded above if there exists a real number we can say that k, capital K, such that this xn should be less than or equal to capital K for all n, suffix n, which is member of natural numbers. Means what? To keep remember, any sequence xn is said to be bounded above if there exists a real number, we can say that k, see that which relates with this nth number of that sequence, number of terms xn, that should be less than or equal to that capital K. That so for all n should be belongs to, that is the member of natural numbers n. So now let us see that a sequence xn is said to be bounded below if there exists a real number. Say we can say that same capital K, such that it is reverse in nature of that n number of sequence xn should be greater than or equal to capital K for all small n should be belongs to, that is the member of natural number n. Now let us see that bounded definition, that because if xn is said to be bounded, if it is bounded both above as well as below, that means if there existed two real numbers k and small k, such that so that small k should be less than or equal to xn, that should be less than or equal to capital K, where this small n, which is the member of capital N, means what? A natural number n. That means what? As you go on like this, so that if you give any number of that natural number, you can see the number, each number, which is the relation between the bounded below as well as bounded below. This is always lies between the each term of the sequence, which always have a bounded below as well as bounded below lies. That so that is what that is. If any sequence is said to be bounded, if there exists a bounded below as well as bounded above, that means any sequential term which has its lower bound as well as its upper bound also, that is what we can say that it is sequence is bounded. So now we shall see the discussion of infimum and supremum. Means what? Greatest lower bounds and least upper bound, that greatest among the lower bounds and least among the upper bounds. That now we shall see that is the infimum. A real number small m is said to be infimum or greatest lower bound of a sequence xn if that nth number of sequence xn is always greater than or equal to small m for all small m is the member of that natural number n. That and second condition for that, for any small epsilon greater than 0 be given, there exists at least one term an such that an should be less than or equal to small m plus epsilon. Means what? That an is always smaller than the, that is the number m, real number m, plus that is the any smallest increment epsilon. That so that is what it is. A real number m is said to be infimum or greatest lower bound of sequence xn, so that if there exists a relation of that real number m with n number of terms in the sequence, so that always that is the xn should be greater than or equal to m, and for all m should be member of natural number n. So next, another one, we can take it any smaller value which is positive, however it is small, there exists one term of that sequence an such that an should be less than plus epsilon. And you go for the another definition, that is the least upper bound or supremum. A real number capital M is said to be supremum or the least upper bound of a sequence section if that nth number of sequence xn, so that that should be less than or equal to capital N, that suffix n, that is small n, which is the member of natural number n. Another condition for that, for any epsilon which is, however it is small, there exists at least one term of that xk such that, so that is the xn, xn is greater than m minus epsilon that. So that is what we have a discussion of this. Means what? Any if you want any sequential term which has its supremum as well as its infimum also, that is what we have at that. So that's always, that is the always which is what you have there here. So that xn or an should be lies between, that is the m plus epsilon less than xn or an, that should be less than, so that is m minus epsilon, greater than m minus epsilon. So now what is the limit of the sequence that? So now let us see that any sequence that it has its own limitation that. So now what is the limited sequence that? A real number L is said to be a limit of a sequence xn as n approaches to infinity if for every epsilon is positive, however it is small, there exists a positive integer small m such that magnitude of that nth number of sequence xn minus that real number, means that is should be very close to each other. Means what? Distance between, that is the nth number of sequence or any number of sequence with that and real number L which is close to each other for any n should be greater than m. So or else we can write it in symbolically as limit of xn as n approaches to infinity, which gives finite real number L. That we called it as a limit of sequence xn that. And another one, a sequence xn is said to be approaches to infinity, that means diverges, so that keep remember that a sequence xn is said to tends to plus infinity if to each positive number capital K, however large in number. So there exists a positive integer m such that xn should be greater than or equal to capital K for all n is greater than m. Or in other way, that is limit of xn as n approaches to infinity, which gives a infinity plus infinity that is what. And next another minus infinity, any sequence which approaches to minus infinity if to each positive number capital K, however large in number, there exists a positive integer small m such that xn should be less than minus capital M for all n should be greater than small m. In other way, limit of xn as n approaching to infinity means if you are going larger in number of that terms of the sequence, which gives finally as m approaches to infinity, which gives minus infinity. So that now we shall discuss some examples based on this definitions there. Limit of sequence. Now we can take a limit of 2n plus 3 by 3n plus 4. Now I wanted to show this as n approaches to infinity, which gives a 2 by 3 by using the definition of limit of the sequence. Let us take here epsilon be positive, be a given real number, however it is small. Now I consider, that is the definition of the sequence, limit of the sequence. So it is the given, that is the xn, though so that it is what here 2n plus 3 by 3n plus 4 minus 2 by 3, it is a real number. So that is what there. Now I wanted to see that it should be less than this. So then once we simplified that, which gives, that is this form, that n term of this one by 1 by 3 and 3n plus 4, that should be less than epsilon that. So it means what? If you take a 3 this side and then reciprocal it,